Not too far from Earth, in the vastness of space just over 4 light-years away, astronomers have fixed their gaze on an intriguing world, Proxima B. Recently, using the revolutionary James Webb Space Telescope, scientists captured the clearest image yet of this alien planet. This breathtaking view into a neighboring solar system has ignited curiosity among astronomers and space enthusiasts across the globe. But how did this distant image come into existence? And more importantly, could this discovery change our understanding of where life might exist beyond Earth? Proxima B orbits a small red dwarf star named Proxima Centauri, the closest star to our own Sun. This new image offers a glimpse into a world that, despite its distance, feels surprisingly familiar. The planet receives a comparable amount of stellar radiation as Earth does from the Sun, which has prompted exciting discussions about its potential to support liquid water, and possibly life. The more scientists examine this rocky exoplanet, the more questions arise. Could it be a parallel version of Earth? Or is it a barren world shaped by forces entirely different from those we know? Adding another layer to the mystery is the presence of another planet in the same star system, Proxima Centauri C. Together, these planets orbit a star just a fraction of the Sun's size, a dim red dwarf that cannot be seen with the naked eye. Yet within this humble system may lie the answers to questions that humanity has asked for centuries. Proxima B, in particular, is notable for its short year, only 11.7 Earth days long. Its tight orbit means one side of the planet constantly faces its star, bathing in endless light, while the other side remains in eternal night. This strange arrangement could lead to wild climate extremes and atmospheric phenomena we can't yet fully comprehend. Proxima B was discovered using a technique called radial velocity, which detects tiny shifts in a star's movement caused by the gravitational pull of orbiting planets. As Proxima B tugs on its star during its orbit, it causes subtle spectral changes, signals that astronomers have learned to interpret with astonishing precision. These tiny variations, invisible to our eyes, led to one of the most important finds in the search for other worlds. The confirmation that a planet orbits in the habitable zone of our nearest stellar neighbor sent shockwaves through the scientific community. Though Proxima B remains a mystery, its discovery is a beacon of possibility. Just imagine a planet so close, cosmically speaking, that it might become the target of future interstellar missions. The nearby Proxima system is shared with 2 bright stars, Regulus and Canopus, which shine prominently in the night sky. But Proxima Centauri, though invisible without a telescope, may hold the key to unlocking one of the greatest questions in human history. Are we alone? Interestingly, Proxima Centauri was only identified in 1915 by Scottish astronomer Robert Innes. Its name, meaning closest star, in Latin, reflects its special place in our galactic neighborhood. Despite being faint, it plays a powerful role. As a red dwarf of spectral type M, Proxima Centauri burns much more slowly than stars like our Sun, and it will continue to shine for trillions of years, outliving most stars in the galaxy. Yet, it's no peaceful neighbor. Known as a flare star, Proxima frequently erupts with violent outbursts of radiation. Any planet within its habitable zone must withstand brutal doses of ultraviolet energy, far beyond what Earth experiences. This presents a critical challenge. While Proxima B sits in the so-called Goldilocks zone, not too hot, not too cold, it doesn't guarantee that life could thrive there. Without a protective atmosphere to shield the surface from radiation, any chance of sustaining life becomes slim. Hydrogen molecules could break apart, oxygen and nitrogen might be lost to space, and the dream of oceans and greenery fades into uncertainty. Proxima B may indeed be in the right place, but it might still lack the right conditions. Still, the mystery endures. Scientists continue to develop tools to peer deeper into this enigmatic world. Could Proxima B be shielded by a magnetic field like Earth's? Might life exist beneath its surface, hidden from radiation? Or is this planet simply a rocky relic orbiting a tempestuous star, forever unreachable yet tantalizingly close? The answers remain out of reach, for now. At Waves Discovery, we believe that every discovery brings us closer to understanding not just the universe, but ourselves. Proxima B is more than just a distant planet. It's a symbol of hope, a whisper from the cosmos reminding us that other worlds are out there. Some may be empty, others teeming with life. But each one offers a chance to glimpse the extraordinary. Stay with us as we continue to explore space's greatest riddles, because this is absolutely. Here is the refined and cleaner continuation of your script, without any asterisks or formatting symbols and written in simple, short paragraphs with precise language. This is the next part continuing directly from the last section. The James Webb Space Telescope is not just about finding planets. It is about finding life, or the conditions that allow life to grow. Each planet we study teaches us more about how special or common Earth really is. Proxima B has captured attention because it could be the first nearby world with Earth-like traits. But that doesn't mean it is friendly to life. We still know very little about its atmosphere, its surface, or its magnetic protection. If Proxima B has a magnetic field, it might shield its surface from dangerous radiation. Without this, its atmosphere could have been stripped away over time. This would leave the planet exposed, dry, and lifeless. But if it kept enough atmosphere, water could still exist in some form. Maybe in deep underground reservoirs. Maybe locked under ice. Or maybe in salty oceans shielded from the heat above. Scientists are modeling all these options to find which fits best. Each new update sharpens the picture of what Proxima B might truly be like. It could be a frozen wasteland. It could be a hot desert. Or it could be something in between, like early Earth before life began. Many scientists believe that if life can exist, it will find a way. This belief pushes the search forward, year after year. We are not only looking for Earth twins. We are looking for any place that could host even the smallest life forms. A few microbes on Proxima B would change everything. It would prove that life is not limited to Earth. It would mean the universe is not silent, just unexplored. Some scientists believe Proxima B could host microbial life today. Others are more cautious and think the planet is probably dead. There is no agreement, just growing interest. What makes this search even more powerful is our new ability to compare. We are now comparing Proxima B with hundreds of other exoplanets. Some are larger. Some are smaller. Some have stronger stars or more protective environments. The more we study, the more we realize how much variation is out there. There is no single type of planet. There are gas giants with endless storms. There are rocky planets with boiling temperatures. There are cold worlds with ice for miles. And some planets might look calm and quiet from space, but hold secrets deep below. This is why the search cannot stop at what we see on the surface. We have to think bigger. We have to dig deeper. And that's what new missions are now planning to do. Future telescopes will be even more powerful than James Webb. They will study exoplanets in more detail than ever before. They will see layers of clouds. They will spot strange gases. They may even capture surface reflections that hint at oceans or land. In the next decade, the hunt for exoplanets will become sharper. Each mission will go further. And the data we gather will grow faster. This is why Proxima B is only the beginning. It is a target, but also a symbol. It reminds us what is possible. It shows how far we have come from blurry telescope images. Today we can find planets by watching tiny dips in starlight. We can analyze their atmospheres from billions of kilometers away. We can guess at their temperatures, pressure, and light. And we can build models of what life might look like there. That kind of progress was impossible just 30 years ago. But today, it's a growing part of astronomy. Entire labs are dedicated to finding the right combinations for life. They look for water. They look for the right amount of heat. They look for oxygen and methane. They even consider exotic chemicals that could support alien forms of biology. Not all life needs to look like Earth life. That's the new idea shaping space research. We might find life that breathes different gases. That swims in strange oceans. or that lives in environments we consider deadly. This is why finding life might surprise us. It might not come with a message. It might not build cities. It might not use technology. It might just exist quietly, like early life on Earth did for billions of years. That is enough. Even the tiniest life form would be the biggest discovery in human history. And Proxima B could be the world to deliver that surprise. We are preparing for that possibility, carefully and slowly. Not with fast conclusions, but with careful observation. New telescopes, space-based labs, and computer models are part of this growing effort. Proxima B is not the only candidate, but it is one of the best-known ones. Because it is close. Because it may be rocky. Because it may have once had the right conditions. Because it pushes us to ask the question again and again. Are we alone? That question drives the heart of space exploration. It fuels satellites, launches, and theories. It inspires students, professors, and astronauts. And it keeps humanity looking up. We may not find life on Proxima B, but we may find clues that life could exist elsewhere. And those clues are enough to light the path ahead. The journey will take years. The discoveries will take decades. But the process has begun. Proxima B is not just a planet. It is a signpost in the universe. It points the way forward. A future where we don't just study stars, but the worlds that orbit them. Where we don't just look at light, but at the fingerprints of biology. Where we don't just dream about alien life. We search for it, with data, with tools, with purpose. And we never stop asking questions. This is just one step in a much larger journey. One day, we might find the answer. Until then, the sky remains open. And our